morning. Hello everyone, how are you? So today we will continue our video for Math 171. So like you all know, last week we had our midterm, so I will check and give you your grades later in the day. So as you know, last time in our last video I defined what an absolute value is. So let's refresh and go back to the definition of what an absolute value is. Like I said last week, an absolute value function is, let's say an absolute value function is the distance between any number from 0. So let's say I want to find the absolute value of x. The absolute value of x is the distance from 0 to x. So absolute value of x on the real number line, the distance of a number x from 0 is called the absolute value of x. It is denoted by bar with x. So I gave an example. Absolute value of 5 is 5 because 5 is 5 units from 0. Absolute value of minus 5 is also 5 because the minus 5 is 5 units from 0. So the distance between a number between 0 and a number is the absolute value of that number. So similarly, absolute value of 0 is 0. Since the absolute value of 5 is 5, absolute value of minus 5 will give you 5 also. So absolute value function will never be negative. It is non-negative. Non-negative we mean 0 upward. So absolute value of 0 is 0. Absolute value of any negative number is positive of that number. So the general definition of absolute value is this: the absolute value of a real number x is defined as bar x if x is greater than or equal to 0. So if x is greater than or equal to 0, absolute value of x is x. Absolute value of x will give you minus x if x is less than 0. So this is the general definition of the absolute value function. So let's see an example and how we apply the definition. Sorry. Find the absolute value of 2, 0, and minus 3. We want to find the absolute value of these numbers using our definition. So solution: absolute value of 2 is 2 because 2 is positive. And from the definition it says absolute value of x is x if x is greater than or equal to 0. So here our x is greater than 0, which is 2, so it's just 2. And absolute value of 0 is 0 also from the definition, because we say x greater or equal to 0, the absolute value of x is x. So minus 3, absolute value of minus 3. If you look at your definition, your x now is minus 3. In the definition we say absolute value of x is minus x if x is less than 0. If you look at the definition and you look at our absolute value of minus 3, our x is minus 3. So now this minus that you see here is the minus from the definition, and our x is minus 3. So minus times minus will give you plus, and it will be plus 3. So that is why absolute value of minus 3 is 3 from the definition. So this is how we evaluate the definition of our absolute value. Next, we have the properties of the absolute value function. It has some various properties, so these are some of the properties. Let a be real numbers. Let a and b be any real number. So property 1 is saying absolute value of a times b is the same thing as absolute value of a times absolute value of b. This is our first property of absolute value. Absolute value of a times b is the same thing as absolute value of a times the absolute value of b. That is the first definition. 2, absolute value of a minus b is equal to absolute value of b minus a. The order doesn't matter, provided they are in the absolute value, because absolute value of 2 minus 3 will give you 1, because 2 minus 3 is minus 1. Absolute value of minus 1 is 1. The same thing as reversing the numbers. 3 minus 2 will be 1, so it will still be absolute value of a minus b is the same thing as absolute value of b minus a. So number 3, absolute value of a over b is the same thing as absolute value of a over absolute value of b, provided b is not 0. Because if b is 0, we will have a absolute value of a over 0, which is not defined. So that is how it is. Now the fourth one is absolute value of a plus b is less than absolute value of a plus absolute value of b. This is what we call the triangle inequality. So absolute value of a plus b is less or equal to absolute value of a plus b. It's not equality, please. Note the difference. Absolute value of a plus absolute value of b is less or equal to absolute value of a plus b. Fifth one is absolute value of a less than or equal to b implies minus b is less or equal to a and is less or equal to b. If you have absolute value of a less or equal to b, it is saying that minus b is less or equal to a and is less or equal to b. And if you have this, minus b less or equal to a less or equal to b is the same thing as this. So each one will give you, each side will give you the other side. They are equivalent. Absolute value of a less or equal to b implies minus b is less or equal to a and is less or equal to b. So also minus b less or equal to a is less or equal to b is implying you that absolute value of a is less or equal to b. So it's if and only if. If this happens, this happens. If this happens, this happens. So this is this. 5 is saying absolute value of a is less than b implies that. So there is similarities between 5 and 6. The only difference is just the sign, the inequality sign. The number 5 is less or equal to, number 6 is just less than. So 7 implies this. Also implies this is less or equal to minus b, or this is less or equal to, sorry, here I'm supposed to put b. Yeah, it's b. So it's a mistake. So absolute value of a is less than or equal to minus b, or absolute value of a is greater than or equal to b. If you have this, is this. If you have that, you have that. The eighth property is minus the absolute value of a is less or equal to a and is less or equal to absolute value of a. This is obvious. Minus, it means a is in between the minus of its absolute value and the absolute value of its positive. So this is this. So let's, here we have examples. Let's apply some of these properties and solve these examples. They are actually simple, but let's see how we apply them. So we have number 1 up to 11. We have 11 examples like we used to do. I will solve some and the rest should be left for you to practice the exercises. So let's see. Number 1, I have absolute value of minus 7 times 3. Absolute value of minus 7 times 3. This is what we want to evaluate. If you look at this, we are multiplying two numbers in the absolute value, and the first property says absolute value of a. This property number 1, absolute value of ab is the same thing as absolute value of a times absolute value of b. Apply it here. You have absolute value of 7 times absolute value of 3, and absolute value of minus 7, sorry, is 7, and absolute value of 3 is 3, so it's 21. We apply this property, and you can also multiply 7 by 3. Minus 7 times 3 is minus 21. Absolute value of minus 21 is 21 if you apply the definition. So this is the first property. So number 2, we have absolute value of minus 3, absolute value of x minus 3 is equal to 2. This is our question. Now, all we want is to find the values or value of x that will satisfy this equation, because if you look at it, it's an equation. We have an absolute value and linear equation, linear inequality or linear equation, something like that. So absolute value of x minus 3 is equal to 2. If you look at our definition of absolute value, I said absolute value of a number is the distance between that number and 0. So we say absolute value of x minus 3 is equal to 2. It means the distance between x minus 3 and 0 is 2. Also, if you look at it, the distance between x minus 3 can be minus 2, because we are saying 2 units from 0. From 0 you have minus 1, minus 2. I have 2 units. From 0 to 1 I have 1, 2. I have 2 units. So this is telling you, this equation states that x minus 3 is a number 2 units from 0. So it can be 2 units from 0 on the right hand side, and it can be 2 units from 0 on the left hand side. So we pick each case, because we don't know which case will answer that. So that is how the absolute value works. X minus 3 is 2 units from 0. So I have x minus 3 is equal to 2, or x minus 3 is equal to minus 2. Why? Because if I have my number line, this is 0, 1, 2 on the right, 2 units. I have 0, minus 1, minus 2, 2 units on the left. So this does either x minus 3 is 2 or x minus 3 is minus 2. Solve for values of x. X will give you 5 and x will give you 1 there. So x equals to 5 or x equals to 1 will satisfy our equation. So let's see. If x is 5, I have 5 minus 3, sorry. If x is 5, I have 5 minus 3, which is 2. If x is minus 1, I have 1 minus 3, which is minus 2, and absolute value of minus 2 is 2. So this is saying any of these numbers will satisfy our equation. So I hope it's okay. So this means that x is 5 or x is 1. Substituting either 5 or 1 will make the equation true, which I just said. 5 minus 3 is 2. 1 minus 3 is minus 2. So you see each number make the equation to be true. For the next example, I have 7 minus 3x is equal to 5. The same case with number 2. 7 minus 3x is 5 units from 0. So it can be 5 units from 0 on this side, that is the right hand side, and it can be 5 units from 0 on the left hand side. So I have x, 7 minus 3x is 5, or 7 minus 3x is minus 5. Please try and see this. Draw your number line. Find 0, let's say 0 is in between, count 5 units on the right, you will end up with 5. Count 5 units on the left, you will end up with minus 5. So this is saying 7 minus 3x is 5 units from 0. So it can be 5 units from 0 on the right hand side, or 5 units from 0 on the left hand side. So we pick either of the cases. So I have, if it is 5 units from 0 on the right hand side, I have 7 minus 3x equals to 5. If it is on the left hand side, I have 7 minus 3x equal to minus 5. So I have this, x is 2 over 3, or x is equal to 4. You can solve this. This is a linear equation. So the only difference between this and linear equation is that this has 2 cases, because it can be some units on the negative side and the same units on the right hand side. So we have 2 cases. Unlike the linear equation, we just have to solve. So this is this. You can check the solutions by substituting the values of x obtained. If x is equal to 4, put it 7 minus 3 times 4. 3 times 4 is 12. 7 minus 4 minus 12 is 5, minus 5. Absolute value of minus 5 is 5, which make the equation very true. So put x equal to 2 over 3. I have 7 minus 3 times 2 over 3. 3 will cancel 3 and you have 2. 7 minus 2 is 5, which is also true. So try and check and clear your doubts. So now x minus 4, absolute value of x minus 4 is equal to minus 3. So now this question is very different from our previous question. Absolute value of x minus 4 is minus 3. This is saying a number is minus 3 units from 0. Minus 3 units, not 3 units. And we know that the absolute value of a number can never be negative. I said this, absolute value of any number is non-negative. So it's 0 or positive. So here we have no solution. Why? Because the question is saying absolute value of x minus 4 is minus 3. So no any number, there is no number that has its absolute value to be minus 3, negative. So you don't have to do anything. This is saying the absolute value of a number is negative, minus 3, which is not possible. But we know that the absolute value of any number is always positive. Hence, the solution set is empty. No any number, and you can try it. Put any number, you know, it will never satisfy what you have, your solution. Therefore, we have no solution. Please try it. Put any number. Put 1. If you put 1, you will have 1 minus 4, which is minus 3. Absolute value of minus 3 is 3. You see, 3 is never equal to minus 3. Put 5. 5 minus 4 is 1. Absolute value of 1 is 1. So 1 is not equal to minus 3. Put minus 10. Minus 10 minus 4 is minus 14. Absolute value of minus 14 is 14, which is not that. So you cannot have absolute value of any number to be negative. So there is no solution for this particular question. The fifth example. This is saying absolute value of minus 4 is less than, x minus 4 is less than 4. If you look at one of our properties, property 6 is saying absolute value of A is less than B implies this. Minus B less than A less than B. So we apply this. If you look at it, it is saying absolute value of x minus 4 is less than 4. So apply the 6th property and you have minus 4 less than x minus 4 less than 4. And you can solve this. This is a linear inequality. And we know how to solve a linear inequality. We did it in our previous topics. So solve this, add 4 to both sides. This should be 0. This should be x, and this should be 8. So the solution is saying any number between 0 and 8, between 0 and 8, any number in between 0 and 8 will satisfy our inequality. So look at it again. We apply the 6th property of absolute value. We have minus 4 less than x minus 4 less than 4. It is now a linear inequality. Solve this linear inequality. Minus 4 plus 4 less than x less than 4 plus 4. So 0 is less than x is less than 8. This is saying the solutions of this our inequality are all numbers between 0 and 1 and 8, 0 and 8. In other words, all numbers between 0 and 8 will satisfy the given inequality. Try it. 1 is between 0 and 8. Put 1. 1 minus 4 is what? Minus 3. Absolute value of minus 3 is 3, and 3 is less than 4. Put 5. 5 minus 4 is 1. 1 is less than 4. Put 6. 6 minus 4 is 2, and 2 is less than 4. But put 0. 0 minus 4 is minus 4. Absolute value of minus 4 is 4. 4 is not less than 4. 4 is equal to 4. So you see 0 has failed. So that is why I say numbers between 0 and 8. Don't include 0 because you have less than sign. So between 0 and 8. Put 8 also. 8 minus 4 you have 4. Absolute value of 4 is 4. 4 is not less than 4. 4 is equal to 4. So any number in between 0 and 8 will satisfy the inequality. In other words, any number in the open interval 0, 8 will satisfy the inequality, because 0 less than x less than 8 is telling you the open interval 0, 8. As I said, another form of representing our solution is the open interval 0, 8, meaning all numbers between 0 and 8. So this is how we solve it. So now, another example, the 6th one. The 6th one is saying 3 minus 2x is less than or equal to 5. Apply the 5th property. And if we go back to our slide, the 5th property is this. Absolute value of A less than or equal to B implies minus B is less or equal to A and is less or equal to B. So look at it, apply it here. It will be minus 5 less or equal to 3 minus 2x less than 5, less than or equal to 5, sorry. It is now a linear inequality. Solve it for x. Add minus 3 to both sides. You have minus 5 minus 3 is less or equal to minus 2x, and it's also less than or equal to 5 minus 3. You have minus 8 divided by minus 2. Like I said, if you divide a linear inequality by a negative number, the sign of the inequality will be reversed. Look at it. I have minus 8 less or equal to minus 2x, which is less than 2. Divide by minus 2, the sign of this inequality will change. So you will have minus 8 over minus 2 greater or equal to x greater or equal to this. So you have that. You have 4 is greater than or equal to x, and 4 is greater than or equal to minus 1. It is telling you all numbers between minus 1 and 4, minus 1 and 4 inclusive from, sorry, all numbers from minus 1 to 4 will satisfy the inequality. Note that when we had less than, in our previous example, I say all numbers between, but now I have greater or equal to, it is saying all numbers from minus 1 to 4. So you start with minus 1 and you end with 4. In the previous example, between, if I say between, you cannot start with between 0 and 8. So don't start with 0 and don't start with 8 also, and don't finish with 8. So this is saying 4 is greater or equal to x and is greater or equal to minus 1. This is our solution. But if you look at it, 4 greater or equal to x greater or equal to minus is the same thing as minus 1 less or equal to x and less or equal to 4. So all numbers from minus 1 to 4 will satisfy our inequality. This means that all numbers from minus 1 to 4 will satisfy the given inequality. Another representation is the closed interval. Why do I use closed interval? Is because I have greater or equal to sign or less or equal to sign. If you have less or equal to sign or greater or equal to sign, you represent it in a closed interval. If you have less or greater, you put it in an open interval. So this is our solution. Try it. In the previous example, when I say between 0 and 8, when we substituted 8 as 0 and 8, we couldn't find our solution. But here, I said from minus 1 to 4, use minus 1. You have 3 minus 2 times minus 1. 2 times minus 1 will give you minus 2. So 3 minus minus 2 will be 3 plus 2, which is 5. Absolute value of 5 is 5. 5 is less or equal to 5, which is true. 5 is equal to 5 and less or equal to. So 5 is less or equal to 5. So you see the boundaries that are included in our solution satisfy the solution because we have satisfy the inequality because we have a closed interval. So this is this for absolute value. So far, this is where we will stop with absolute value. If you have any question, solve the rest of the examples. If you have any questions, send me an email and I will respond. So try it first. If you have any difficulties, so let me know. So next topic, I finish with the chapter of inequality and absolute value. The next one will be the coordinate system, midpoint formula, and the distance formula. So let's see the definition. In geometry, a coordinate system is a system which uses one or more numbers or coordinates to uniquely determine the position of a point. This is the definition of coordinate system. In geometry, in the real number, you have a point, let's say 2. This point is representing 2 on the real number line. So let's leave this topic till the next video. So in the next video, we will start with the coordinate system, midpoint formula, and the distance formula. So see you. Bye bye.